Good morning, everyone. My name is Christina Ibasan. Today, I'm going to discuss the Module 1 in Forensic 3. So, the topic that I'm going to discuss are scope of forensic chemistry, practice of forensic chemistry, factors that must be considered when collecting specimen for examination, role of forensic chemistry in the scientific investigation, the 6 golden rules in the practice of forensic chemistry, duties and responsibilities of forensic chemists, and equipment used in forensic examination, and the last is reservation and safekeeping of evidence. So first is the scope of forensic chemistry. The scope of forensic chemistry will also include the application and or development of any molecular and atomic spectrochemical technique and electrochemical techniques, sensor surface characterization techniques, mass spectrometry, nuclear magnetic resonance, chemometics and statistics, and separation science, and that provide insight into the forensic analysis of materials. Forensic Science International published original contribution in the many different scientific disciplines pertaining to the forensic science. Fields include forensic pathology and histochemistry, chemistry, biochemistry, and toxicology, including drugs, alcohol, etc., biology, including the identification of hairs and fibers. Serology, odontology, psychiatry, anthropology, the physical science, firearms, and document examination, as well as investigation of value to public health in its broadest sense, and the importance marginal area where science and medicine interact with the law. Forensic science and its scope. Forensic science is the branch of criminal science that involves the application of scientific concept in the identification of criminals, analysis of crime scene, advanced diagnostic techniques, innovative testing kits, and the use of advanced instruments and tables. The scope of forensic analysis. The main task for forensic science is that to get adequate result and fact by determining factors in the ability of evidence to adequately represent the fact of the case. Forensic chemistry entails using chemical approach to investigate physical evidence. Forensic chemists examine evidence gathered from crime scene and provide conclusive testimonies based on lab results. The analysis of the accumulated proof help law enforcement figure out the source of the crime or who is the criminal. Samples of examined evidence consist of DNA samples from materials such as hair and blood gathered from the crime scenes, such as soil, paint traps, and glass pieces, and etc. The forensic chemist must have an understanding of the various fields including biology, genetics, physics, toxicology, and also materials in science. Forensic chemists analyze non-biological trace evidence present at crime scenes in order to identify unknown materials and match samples to no substance. They also evaluate drugs, controlled substance extracted from science and people in order to identify and sometimes quantify their materials. Must-know techniques in forensic chemistry. Knowledge of the below-mentioned techniques can be used to have a successful career in forensic chemistry. Spectroscopy techniques are used to check the purity of materials. Using identification and separation techniques for detecting illegal drugs and narcotics. Different chromatography techniques are used to identify trace amount of drugs and poisons in the body. Scanning electron microscopy, neutron activation, analysis, and energy dispersive spectrometry to identify and gunshot residues and post-exclusion debris. Laser ablation, inductively coupled plasma mass spectrometry is used to examine the structure of glass on an atomic level. Carbon-14 dating uses the level of carbon-14 present in a sample to determine the age of fossils and other substances. During testing is conducted to determine if there are drugs present in an otherwise unknown substance. Chemistry. Chemistry is a branch of science that deals with the study of composition of matters and different changes that is undergoes. Forensic chemistry. So forensic chemistry is a specialized subfield of forensic science involving the application of techniques and principles of chemistry to the field of forensic investigation. Involves complex procedures of chemical analysis that are needed to identify elements and compounds. Identification procedures are highly reliable. Identification is based on the physical and chemical properties of the substance, supported by the data obtained from analytical analysis. Forensic chemists analyze non-biological trace evidence found at crime scenes in order to identify unknown materials and match samples to known substance. Forensic chemists task: analyze any non-biological materials found at crime scene. Link the suspect to the crime. Determine the chemical makeup of the material. Examination of low standard construction materials like current, bricks, and etc. Examination of metal alloys and metal fragments. Examination of inflammable materials in suspected cases of death. Next is analysis of explosive firearms ammunition. Analysis of dyes, point ink, fells, benders, and various other chemicals like capsilin spray, tear gas. Drugs, screening of athletes. Trap cases, analysis of permitted wash, varnish, etc. in probation and excise cases. Analysis of pesticide and insecticides. Practice of forensic chemistry. There are 4 stages in this practice of forensic chemistry. First is microscopical examination, second, staining test, third, salability, fourth, chemical and physical method of analysis. Stages on the practice of forensic chemistry: separation, second, identification, third, quantitative, fourth, distinction. Main function of forensic chemistry. Forensic chemists apply the scientific method to have investigation of evidence used by law enforcement agencies and to the analysis of materials and systems in the manufacturing industry. Characteristic of a forensic chemist. Versatility and patience are the most often cited qualities of a forensic chemist. Forensic chemists must be able to spend hours vigorously applying analytical techniques to evidence and defending their works in a court of law. They must be able to clearly and concise answer challenges to their findings. Forensic science discipline. Lists of forensic disciplines are usually a mixture of scientific fields, tasks, occupation, and service, such as anthropology, ballistic, biology or DNA, chemical, criminalistic, clandestine, laboratories, crime scene examination, document examination, fingerprints, illicit drugs analysis, computer forensic, digital imaging, audio-video analysis, entomology, mortuary service, odontology, and toxicology. Branches of forensic science. First, trace evidence analysis. Going by record principle that everything leaves a contact. Trace evidence analysis provide crucial link to the perpetrator. Trace evidence is anything that is transferred during the commitment of a crime, such as human, animal hair, rope, soil, fabric fibers, feathers, building materials, etc. Trace evidence analysis involve the recovery of such evidence and their forensic examination to obtain information that can be used in the court of law in association with a case or to answer any other legal query. Second, forensic toxicology. Forensic toxicology is the study of the presence of toxic substance inside a body and the effect that they had on the individual. It encompasses methods and procedures from various disciplines such as analytical and clinical chemistry, and pharmacology to aid in the medical and legal investigation of death due to poisoning or drugs. This branch of forensic science is of prime importance in road accident, poisoning, and sexual violence. Third, forensic psychology. Forensic psychology is the application of psychology to legal and criminal matters. Forensic psychologists study criminals and their crimes to draw conclusion about the personality traits of the perpetrators and thus assess in criminal profiling. Criminal profiling involves giving a detailed description of the personality and behavioral traits of the criminal. Forensic psychologists perform multi-faceted tasks, some of which are counseling victims of a crime, evaluating child custody, death notification procedures, and evaluation of post-traumatic stress disorder. Fourth, forensic podiatry. Forensic podiatry deals with the application of specific podiatric knowledge, including an understanding of the abnormalities and disease of the ankle, foot, and lower body and lower limb anatomy and musculoskeletal function. This is particularly helpful in the investigation of foot-based evidence with suspect to a criminal incident. Fifth, forensic pathology. The branch of pathology that deals with the examination of a corpse to determine the cause of death is called forensic pathology. It involves the deduction of facts admissible in the court of law by collecting and analyzing medical samples. For example, a forensic pathologist can examine a wound to identify the weapon used to cause death. Therefore, forensic pathology helps draw crucial inferences on whether the death is natural, criminal, or accidental. 6. Forensic odontology. Forensic odontology or forensic dentistry involves the proper handling, analysis, and evaluation of any form of dental evidence that would be later used as a legal evidence in the court of law. Often when the victim's body is left in an unrecognizable state, it is forensic odontology that helps investigators in identifying them. Forensic dentists play a crucial role in the comparative identification of a person by analyzing the development and anatomy of that teeth, including filing or other restorative dental corrections. Criminal investigations, comprising bite marks, largely involve the discipline of forensic odontology. 7. Forensic linguistics. Forensic linguistics involves the application of linguistic knowledge and method to criminal investigations and judicial proceedings. Such linguistic experts are skilled at analyzing the written and spoken language of a perpetrator to draw crucial inference about the offender's age, gender, educational level, culture, ethnicity, socioeconomic, and geographical background, and for that matter, even spiritual and religious beliefs. They are involved in the careful examination of forensic tests such as emergency calls, demands of ransom, suicide notes, social media, and death row statements. 8. Forensic geology. Forensic geology or geoforensics deals with the examination of forensic related to materials found in the earth such as oil, petroleum, minerals, soil, rocks, and the like. Such examination is associated with the forensic context such as investigation and answering questions put forward by the legal system. Thus, forensic geologists analyze earth materials recovering from the incident scene, victim or suspect to strengthen evidence against the suspect, draw inference about the time and cause of the accident, and to obtain other relevant information as a part of the investigation. 9. Forensic entomology. Forensic entomology involves the application and study of the biology of insects and other arthropods such as arachnids, centipedes, millipedes, and crustaceans to solve criminal causes. Due to the presence of such organisms in decomposing runs, forensic entomology is primarily used for death investigation, determination of the location of an incident, postmortem interval, and to arrive at the precise time of the infliction of wound. 10. Forensic engineering. Never thought that there would be a different branch of forensic altogether for the investigation of products, materials, mechanical components, or structures that fail or are unable to function as desired, resulting in personal injury or property damage. Well, that is what forensic engineering is all about. It involved the application of engineering principles for the investigation and analysis of such mechanical and structural failures. 11. Forensic DNA analysis. In addition to fingerprints, DNA is the other biological parameter which is unique to a particular individual. DNA profiling is a commonly used forensic technique in criminal investigation for the identification of any anonymous person or to zero in the perpetrator. The biological evidence used for DNA profiling included hair, skin, semen, urine, blood, saliva, and even body remains in born cases. 12. Forensic botany. As is evident from its name, forensic botany is the study and examination of plant-based evidence such like leaves, flowers, wood, fruit, seeds, pollen for criminal and non-criminal investigation and for answering other legal questions. Though it is still quite underutilized in forensic investigation. Application of botany in criminal investigation have helped investigators in the past to ascertain the manner and time of death in certain complex cases. Botanic trace evidence recovered from an incident since often help in establishing crucial links to the suspect. 13. Forensic archaeology. Wonder how geophysical and geological surveying techniques are used in forensics. That forensic archaeology for you such techniques along with the use of photography and imaging enable forensic archaeologists to assist the police and investigating officers to identify the site where the victim's body and personal items or robbed goods are buried. Forensic archaeologists are also often leveraged for carrying out excavations or digs at historical and prehistorical sites. Such scientists are adept at using a range of techniques, one being carbon dating to ascertain the age of items retrieved during an excavation. They often carry out mass excavations to produce evidence for war crimes, trials, gas or bomb explosion, plane crash, and the like. 14. Forensic anthropology. In the course of an incident, bodies are sometimes rendered unrecognizable due to manipulation, burning, natural degradation, etc. In such cases, forensic anthropology came into the picture. Forensic anthropologists can examine human bodies, skeletons, to help identify the individuals and arrive at the cause of death. They are skilled at determining the age, sex, race, and physical of an individual from the bones or bone fragment. Additionally, they can also determine the matter of death, suicide, accidental, or due to disease, as well as if a bone injury retrieved was before, during, or after the death. 15. Digital forensics. Digital forensics is the current buzzword in the world of forensics. It involves the extraction and analysis of digital evidence such as those found in computers, hard disks, USB drive, and etc. using the most powerful forensic tools. It is mostly used in the investigation of cybercrimes. Digital forensic is also associated with the criminal law where the digital evidence recovered is used to support or counter a hypothesis in the court of law. 16. Forensic ballistic. Forensic ballistic involves the analysis of any evidence related to firearms, like bullets, bullet marks, shell casing, gunpowder, residue, and etc. This branch of science is particularly used in the investigation in accident involving the use of firearms. To draw inference on the exact weapon used, the distance, velocity, and angle of firing, and also ultimately the shooter himself. What branch of forensic studies bullet? In forensic science, the study of ballistic is the study of motion, dynamics, angular movement, and effect of projectile units like bullets, missiles, and bombs. How does forensic chemists practice their profession? Forensic chemists analyze evidence collected from crime scene and give conductive testimonies based on laboratory test results. While some forensic chemists do their work in law enforcement crime laboratory rather than at actual crime scene, they are also expected to present their findings at legal proceedings. Forensic chemistry is important because without it, we wouldn't know the outcome of a crime. The forensic chemistry job is to examine evidence given to them from a crime scene when it happened and even who committed the crime at times, and which is also frequently used trace it provides the strongest evidence in court. What is forensic chemistry in criminology? Forensic chemistry is the application of chemistry to criminal investigation. Focuses on the chemical analysis of substance connected to a crime. Mass spectrometry. It is the analytical technique that measures the mass to charge ratio of charged particles. It is used for determining masses of particles. Forensic science is the application of scientific knowledge in the criminal justice system. A forensic chemist uses the principles and techniques of chemistry to analyze physical and evidence without a crime lab. Factors to consider when collecting specimen for examination. Laboratory tests contribute vital information about patient's health. Correct diagnostic and therapeutic decisions rely in part on the accuracy of test result. Adequate patient preparation, specimen collection, and specimen handling are essential prerequisite for a accurate test result. The accuracy of test result is dependent on the integrity of specimens. Safety and disposal consideration in specimen collection. In all settings in which specimens are collected and prepared for testing, laboratory and healthcare personnel should follow current recommended sterile techniques, including precaution regarding the use of needles and other sterile equipment. Treat all biological material as material that is potentially hazardous as well as contaminated specimen collection supplies. For all those who are involved in specimen collection and preparation, the responsibility to adhere to current recommendation designed to maintain the safety of both patient and health workers does not end when the patient is dismissed. There are four steps involved in obtaining a good quality specimen for testing. First, preparation of the patient. Second, collection of the specimen. Third, processing the specimen. And fourth, storing and or transporting the specimen. Since information related to any of these areas may change as clinical laboratory technology changes, please refer to the latest edition of the LabCorp Directory of Service and Interpretive Guide for current instructions. Preparation. Prior to each collection, review the appropriate test description, including the specimen type indicated, the volume, the procedure, the collection materials, patient preparation, and storage and handling instructions. Preparing the patient. Provide the patient in advance with appropriate collection instructions and information on fasting, diet, and medication restrictions when indicated for the specific test. Preparing the specimen. Verify the patient's identification. Proper identification of specimen is extremely important. All primary specimen containers must be labeled with at least 2 identifiers at the time of collection. Submitted slides may be labeled with a single identifier, but 2 identifiers are preferred. Example of acceptable identifiers include but are not limited to patient's name, patient's first and last name, exactly as they appear on the test required form, date of birth, hospital number, test request form number, association number, or unique random number. A location such as a hospital room number is not an appropriate patient identifier. If chain of custody documentation is necessary for the procedures, follow the appropriate protocol. All specimens should be labeled in the presence of the patient. Process and store the specimen as required. Appropriate storage and handling are necessary to maintain the integrity of the specimen and constantly the test result. Avoid common problems. Careful attention to routine procedures can eliminate most of the potential problems related to specimen collection. Materials provided by the laboratory for specimen collection can maintain the quality of the specimen only when they are used in strict accordance with the instructions provided. To collect a sufficient quality of such type of specimen indicated for the procedures to be performed, please consult the volume requirements published in this directory. Role of forensic chemistry in the scientific investigation. A forensic chemist is a professional chemist who analyzes evidence that is brought in from crime scenes and reaches a conclusion based on tests run on that piece of evidence. A forensic chemist's job is to identify and characterize the evidence as part of the larger process of solving a crime. Forensic chemists rarely conduct any investigative work. They handle the evidence collected from the crime scene. Evidence may include hair samples, paint chips, glass fragments, or blood stains. Understanding the evidence requires tools from discipline including chemistry, biology, material science, and genetics. The prevalence of DNA analysis is making knowledge of genetics increasingly important in this field. Life of forensic chemist working condition. Forensic chemistry generally work in government labs where they spend time analyzing evidence, assessing data, and giving testimony in court. Over the last 15 years, the field has opened up to women who are moving up in the ranks. 6 golden rules in the practice of forensic chemistry. First, go slowly. Second, be truth. Third, take notes. 4, consult others. 5, use imagination. 6, avoid complicated theories. Go slowly. Take all time to make the test complete, no matter how urgent or pressure is given to release the result. Be truth. Make careful observation and conduct all sufficient analysis. Take notes. Use laboratory notebook to record all your observation. Consult others. Consult others who know the case or already handle the same case. Use imagination. Be imaginative and think ahead the outcome of the analysis done. Avoid complicated theories. Explain in layman terms to understand chemical language easily by non-expert. Duties and responsibilities of a forensic chemist. 4 responsibilities of forensic chemists. First, obtaining evidence that the crime scene. Second, creating reports of the findings. Third, analyzing evidence in the lab. Fourth, testifying in court. Forensic chemists analyze non-biological trace evidence found at crime scene in order to identify unknown materials and match sample to known substance. They are also analyze drugs, controlled substance taken from the crime scene, and people in order to identify and sometimes quantify these materials. Working in a lab, they run tests on samples collected by investigators. They are used a variety of techniques including microscopy, optical analysis such as UV, infrared, X-ray, gas, chromatography, and other technologies. They carefully document their findings and write reports that are used to support criminal investigations. Forensic chemists may also testify to their findings in court. Equipment used in forensic examination. Forensic laboratory equipment range from instrumentation you would see in a general laboratory such as microscopes, fume hoods, chromatographs, and spectrometers to equipment used for specific forensic analysis like kyanoracrite, framing chambers for lifting of latent fingerprints. Alternative light sources are used frequently both at a crime scene and in the laboratory. In addition to cameras and video recording devices, analysis of digital evidence like phones and computers requires high text extraction software and analysis tools. Preservation and safekeeping of evidence. From crime scene to forensic laboratory to courtroom, all evidence must be identified, inventoried, and secured to preserve its integrity. It is important to demonstrate that the evidence introduced at trial is the same evidence collected at the crime scene and that access was controlled and documented. An understanding of an adherence to the rules governing chain of custody is vital for an investigator to ensure evidence admissible in court. Effective evidence preservation includes appropriate packaging with correct and consistent information on labeling and procedural documentation for all items. Biological evidence should be air-dried before packaging to minimize degradation. Packaging in paper is preferred. However, some laboratories allow packaging in plastic if the sample is thoroughly dry. Liquid samples such as water from a toilet bowl or pipes should be properly documented and packaged in sterile glass or plastic containers and refrigerated as soon as possible. Reporting eliminates for evidence submission and laboratory forms may include agency identification, names of suspect and victim, numerical agency case identifier, characterization of the violation, date and location of the crime, investigative summary of the incident, related photographs and other crime scene documentation, description of the items of physical evidence, including the corresponding items number, list of requested examinations, notation of interrelated past or current case, reference to any relevant previous submission, request for expedited treatment of the case, chain of custody including method of delivery. Testifying. The well-documented research of forensic DNA analysis method, along with the National Quality Assurance DNA standards, limit the challenges against the underlying science used in the forensic DNA laboratories. However, the investigator may encounter challenges originating from evidence identification, note-taking, collection procedures, and proper chain of custody. All law enforcement notes, reports, photographs, laboratory analysis, report, and chain of custody records are kept in the case file, which is made available to the prosecution and is subject to discovery by defense counsel. The chain of custody operates like a chain. If one link is broken, the chain breaks and the evidence may be ruled as inadmissible. Priority of collection is determined by environmental condition and the nature and potential evidentiary value of the evidence. Standard or reference sample are controlled for comparison purposes from individuals who may have access the scene. Necessary collection equipment should be presumable in the response kit. The kit should include personal protection equipment and materials for collecting, preserving, and packaging evidence. Biological evidence requires specific handling to guard against cross-contamination from the investigator or between biological specimens. Collection procedures are determined by the situation, location, and the state and the type of sample. Labels list specific from when and where evidence was collected and may include biohazard information. The packaging process for biological evidence include specific precaution to prevent contamination, loss, and degradation. Evidence integrity and appropriate storage conditions are critical for evidence preservation. A complete chain of study and the detailed report are essentially components of case documentation. Courtroom testimony is a critical aspect of the investigator's duties. Correct collection procedures and accurate documentation support the investigator's ability to provide effective testimony. Importance of crime laboratory in criminal investigation. Crime laboratories offer forensic science service to criminal justice system. Forensic science applies scientific testing method and technologies to collect, preserve, process, and analyze evidence. Proof of guilt or innocence is frequently determined by the result of forensic evidence. Crime laboratory in the Philippines. In the Philippines, there are existing PNP Crime Laboratory Office, 5 NCR District Crime Laboratory Office, 16 Regional Crime Laboratory Office, and 101 Provincial Crime Laboratory Office offering autopsy, DNA examination, drug test, examination of altered erased document, counterfeit bills, and fingerprints. Local principles. So, when two objects come in contact, there is a transfer of materials. 4 departments commonly found in the crime lab. First, biology. Second, physical science. Third, ballistic. And fourth, toxicology. That's all. Thank you.